Okay, good afternoon. Good afternoon. You're welcome to review on pharmaceutical calculations. And I don't know if you can remember, I told you that the pattern we use in this review is to really maybe question oriented, because we have this August, right? September. You people are resuming in October. Then October to write your exam. Second years are writing their own exam, are doing their own lectures. But if you've been following, I used to post the lectures I have with them. Maybe I will look for older ones from the time I started with them. I'll post it. I'll repost it again so you can listen to those lectures I had with them. It will help you also to know where to. A kind of revision plus the one we are doing here. You write your own by October before they write their own. I think theirs should be around November. So that's why I want us to really do it by this question-oriented pattern. I don't know if I'm communicating. That's what I told you to. On your normal, by now I believe you are studying the course. Then if there's any particular area you are having issues with, you can bring it up here. We'll look at it and so I don't know if it's okay. I think I told you something like that last weekend. So I don't know if there's anything like that. Okay. 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 Gideon, did you do anything? Measurements. Density. Okay. Okay, let's see. Let's look at the course material then. From the order of the lectures, the proportion came first, followed by the next one you mentioned is after proportion. Based on what you mentioned, those topics for pharmaceutical measurement, then specific gravity and okay, let's see. Let's see. Let's see what we have here. Okay. 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 Based on the topics you raised now, we'll start from ratio. Topic is ratio, proportion, and what? And variation. Do you have issues in variation? Joint variation. You don't have issues in variation. So the main issue is where? Here. Here, although this ratio and proportion are the same thing, because a proportion has two ratios. We have two ratios in a what? proportion. Two ratios that are equal, equivalent ratio, two ratios that are equal make up a what? Proportion. That's why we say if you have A is to B, A is to B, A is to B is the setting as saying what? A over what? B. Now, but if this A over B now is equal to another ratio, C over what? D, it becomes a what? Proportion. So two equivalent ratios form a what? Proportion. So once this ratio is equal to another ratio, that means it forms a what? Proportion. A ratio has two terms, first term, second term, while a proportion has four terms, first, second, third, fourth term. Am I communicating? So this is basically what it's all about. So when a question is being asked, sometimes you may see a question that may warrant you to. Maybe you have a question, just look at the question, you find out that a question in proportion always come in form that you have four terms there. You will be given three terms and asked to find what? One term. So and the two terms in that question may be the same units. And the other two may be the same what? Units. You will ask to find the other term. So you see that to set the what? Proportion, equate them to be able to do what? Find what you're looking for. Am I communicating? So based on that now, I'll leave this here on this board now. Then we'll look at the question. Do you have any question there on the proportion? Let me use it to explain what I mean. Remember the basic thing in proportion is that a proportion has what? Two ratios. Two equivalent what? Ratios. This is the first ratio. This is the what? Second what? Ratio. When they are equal, they will form a what? Proportion. So you have to equate them. It's after equating them that is that if you now want to find a particular term, you do your what? Cross multiplication. If you want to find a particular term of this proportion now, you do like that's what you now do cross multiplication by using. If you cross multiply this now, you have something like this. This will times this equal to this will times what? This. You now have A times B will now become what? Equal to what? Sorry. A times D, right? Become equal to what? B times what? C. This is a powerful relationship that you must learn how to use before you can solve any question in proportion. If you don't know how to use this relationship, you have issues. So if it is A you are looking for, you do what? Divide both sides by what? D to find A. If it is D you are looking for, you do what? Divide both sides by what? A. If it is B you are looking for, you divide both sides by what? C. If it is C you are looking for, you divide both sides by what? B. Is it clear? Any question on that? Now get a particular a problem. Let's use it to solve to explain it better.
If an insulin injection
Okay.
100 units of insulin
Yeah.
each unit.
Okay. If an insulin to do what?
If an insulin injection
Contain what?
contain 100 units of insulin
100 units per what?
per liter.
Per what?
Milliliter.
Meal, okay? Good, per meal.
How many ml should be injected to receive 40 units of insulin?
How many meal?
Should be injected
To see what?
to receive 40 units of insulin.
I'll go back to the question again.
If an insulin injection contains 100 units of insulin
Okay.
in each meal,
Okay.
how many meals should be injected to receive 40 units of
So from this now, what it means is that one meal contains what? Contains what? 100 what? Is it clear? Now you are told that you don't know how many meals that will contain what? 40 what? Units. You find this X. Is it clear? This is the volume. This is the amount. True of us. The amount of insulin there, but this is the volume of the entire what? Injection. The same thing. Have you not seen now that bringing this equation now? Let me bring this proportion back to this place. It will look like this. Remember, this is unit over what? Male. So this will be like A over what? B. True of us. True of us. So, and this will be like another what? B. But you don't know what C is. True of us. So we will be, if you use A, B, C to replace this now, it means that B contains what? Contains what? A. While what? C contains what? Contains what? B. Is it clear? Now, this thing we normally say here, when we do something like this, 1 male contains 100 units, therefore X male will contain what? 40 units. We do what? This is what we have been doing here, sis. Are we together? So all you need to do is just simply do what? Cross multiply. Cross what? Multiply to find this X, which is the number of male that will contain what? 40 what? Units. So if you do it now, we have that X is now equal to what? Basically, let's put it in this straight form. You get what? X times 1 male, right? Times what? 40 what? Units. Is equal to what? Good. 100 watts. Unit times what? X. Is it clear? But we are looking for X. So we have both sides by what? 100. True of us. So this will become what? 100 watts unit over what? 100 watts unit. This will cancel this. Unit will cancel what? We are left to what? Male. So if you divide 40 by 100, we have what? 0.4, right? Times 1 male, you have what? 0.4 what? Male. Is now equal to what? X. So the answer 0.4 male will contain what? 40 units of what? Insulin. So if 1 male contains 100 units of insulin, therefore 0.4 male will contain what? 40 units of what? Insulin. Is it clear? So the basic thing in proportion is to understand that proportion contains two ratios. Watch out. Let's look at it. The first ratio in this question now. The first ratio in this question now is what? 40 is what? The first ratio is 100 mil over what? Over what? 100 mil over what? 100 units over what? 1 mil. This is the first ratio. It's equal to the second ratio. 40 what? Unit over what? We have gotten S to be what? 0.4 mil. I follow you. 40 units over what? 0.4 mil. Watch out. If you divide these two things, they will be equal. Just do 100 units. 100 units divided by 1 mil is what? 100 mil units per what? Per what? Per mil, right? Good. Now do 40 units divided by 0.4. 40 units divided by 0.4 mil. On 100. It is what? 100 units per what? Is it clear now? Are they not equivalent ratios? So these two equivalent ratio forms a what? Proportion. Simple. Any question you are solving again on this, you must be applying this and getting your answer. There's no long story there. We can solve as many. Just after today, just go back, go to that proportion, get questions there, solve as many as possible. This, you must be applying this you are seeing there. And once you apply it, you get it. The most important thing is to know which one is the first term, which one is the first proportion and first ratio, and which one is the what? Second ratio. If you know it, it will take you time to solve whatever you want to solve. If you have another question on ratio proportion, you can bring it up. Let's solve. At least if you solve up to 3 different questions on this, I think you can solve any question on your own. on proportion. Another one. All right. Wait, let me clean the board. I call the question.
Each tablet of Tylenol.
Each tablet of what?
Tylenol.
So one tablet, right?
With codeine
Contain
contain 30 milligrams.
what?
30 milligrams of codeine sulfate.
Of what?
Codeine sulfate.
Codeine what?
Sulfate.
Sulfate.
And 300 milligrams of
Acetaminophen. Plus what?
300 milligrams
Of what?
acetaminophen.
Acetaminophen. That is paracetamol. Okay.
By taking 2 tablets daily for a week, how many milligrams?
If you take what?
2 tablets daily.
2 tablets what?
Daily
For a week.
The question is, how many milligrams of each drug will the patient take?
How many milligram? Of each drug
Will the patient take?
with the what? Patient what?
Patient take.
Call the question again.
Each tablet
Okay.
of Tylenol with codeine contain 30 milligrams of codeine sulfate, phosphorus, sorry, and
Codeine what? Phosphate.
phosphorus. I made a mistake. Phosphate, sorry.
Phosphate. Okay. Phosphate. Not sulfate. Phosphate. Let me correct it. Codeine what? Phosphate. Okay.
And 300 milligrams of acetaminophen.
Okay.
By taking 2 tablets daily for a week,
Okay.
and the question is, how many milligrams of each drug will the patient take?
Okay. Now look up. The question says that one tablet that if you get that drug, the drug is in tablet form, right? The medicine is in tablet form. If you get one tablet inside the medicine, there are 2 active ingredients inside it. That's the meaning, right? There are 2 active ingredients inside the what? One tablet, and the one of them is what? Codeine phosphate, and codeine phosphate. The strength of it is what? 30 milligram. The second one is what? Acetaminophen, which is what? 300 milligram inside one tablet. And you say that 2 tablets should be taken for daily for what? A week. 2 tablets should be taken daily for a what? A week. Now look at this one. This one is simple, sir. Since you know that one tablet contains 30 milligram of what? Codeine, and 300 milligram of what? Acetaminophen, and the person will take 2 tablets daily for a week. First of all, you know what? How many days are in what? A week. How many days are in a week? 7 days. And the patient is going to take 2 tablets daily. So 7 days, the patient is taking how many tablets? For 1 week, there are 7 days. And the patient should take 2 tablets daily. So for that 1 week, how many tablets will the patient take? 14 tablets. Now we now use it to form a what? Proportion. Am I communicating? Now look at it now. Since 2 tablets, for complete 1 week, the patient will take 14 tablets. Now, before we know how many milligram of each of these drugs enough the patient will take, we now find out how many milligram of each drug will be in that 14 tablets. Since there are 300 milligram of choline phosphate, we'll solve it individually, but they say how many milligram of each of the drug. So we solve it individually. If a tablet contains 30 milligram of choline phosphate, how many milligram will be in 14 tablets? Is it clear? Now, a tablet contains 30 milligram of what? Choline phosphate. One tablet contains 30 milligram of what? Choline phosphate. 14 tablets will contain what? X. Is that not a proportion? So we will now know how many milligram will be in 14 tablets. What do we do? Cross multiply. So if we cross multiply, we have that X is now going to what? Tell me. Oh, okay, let's break it down. It's okay. I like it like that. S what? Please don't throw away the unit. It's important, okay? It will help you not to make mistake. Don't just throw away the unit, okay? S times what?
1 times X.
Huh?
1 times X equal to
1 tab, right? Times what? Is equal to what?
14 times.
Good. 14 tabs, right? Times what? All over what? Okay, so then good. We make X the sort of formula, right? So X becomes what? Times what? 30 milligram, right? All over what? 1 tab. The answer is what? Simple. Good. Remember, do you know why you should put the unit? The tab will do what? We are left with what milligram? This is 1. So 14 times 30 milligram is what? Good. 420 what? Milligram. This 42 milligram is for which drug? Choline phosphate, right? Good. So that means the patient will take 420 milligram of what? Choline phosphate for that 1 week. Now let's solve for acetaminophen. We use the same pattern since we know that the patient will take 14 tablets, and it is inside that 1 tablet that you also have what? 300 milligram of what? Acetaminophen. So let's set another what? Proportion. We now say the same 1 tablet, this same tablet also contain what? 300 milligram of what? Are we together? The same 1 tablet contains what? 300 milligram of what? Acetaminophen. So if the same 1 tablet contains 300 milligram of what? Acetaminophen, that implies that 14 tablets will contain what? S. Sorry. We cross multiply again, right? We have what? 1 tablet times X is now equal to what? 14 tabs times what? Good. 300 what? Milligram. That means that X is now equal to what? 14 tabs times what? 300 what? Milligram. All over what? 1 tab. Again, tab will do what? Cancel tab. So we are left with what? 14 times 300 milligram is what? 4,200 what? Milligram. So that means for that 1 week, the patient will take 420 milligram of what? Choline phosphate and 4,200 milligram of what? Acetaminophen. So, any other question you are solving on this will just be based on, once you understand this basic thing we did here, this is summary of all this long story you see in the material. Once you understand this, there's no question you will see I remember what I told you, that majority, in fact, 90% of the calculation you are going to do in PharmCalc is based on this. If you don't understand this, you get really issue in PharmCalc, because most of the questions you see, if you take it well, is rooted in this. Yes. Kodamo, yeah. Yes. Yes, nice. Yeah. That is sweetness of IT. You see the drug itself, you see it. Yes. So once you understand this, there's nothing you cannot solve it from. At least majority of the question you can solve, because most of the questions, even if you have not covered the topic, if you see the question, you can, like now. Are you aware that this thing you are seeing here now is dosage calculation? Are you aware? This is dosage question now. How dosage now? So before you can even do dosage calculation, you must know your what? Proportion. You must know your, even the first one we did about insulin is still what? Dosage. That's why I say that proportion is very important. That is in fact, if you know proportion, there's no PharmCalc exam you go. Quote me anywhere you go. If you know proportion very well, there's no PharmCalc exam you will go. You will score less than 60%. It's not possible. See whether the other 40 was a question from other source that doesn't have what? Proportion. There is no question you will see, you will not know how to, it's not possible. You may not get 100, but at least you should pass that exam if you know proportion very well. That's the truth. So I don't know if there's any other question there, let's solve. Or have you raised, please see after today, please, what I want us to do now, within this 1 week, I want us to raise those, this thing. The more questions we solve, the better. We spread it across different topics. The more we solve, the better you get used to it, so that once you get your exam more, you see that the exam will be very easy for you. It's not the issue of passing the exam. I want you guys to know this course very well. It's very important in everything you are doing. That's why I'm insisting you should know it. So please, I wanted to solve as many questions as possible. Not dwelling in only one topic. We can cut across different topics. Run them down, then come back again, just like that. So, because it's more of what? If you do it throughout this August, do it September, there's no way there's no way you will not pass PharmCalc. Not just passing, you pass it and know it, because you are supposed to do what? Know it, not just passing it. So, if there's any other question, bring it up. Let's solve it. Huh? Call it.
If a 5-gram packet of...
I'm coming. Stand there. Let me clean the board. Okay, call it.
If a 5-gram packet of potassium supplement...
5-gram packets of what?
Of a potassium supplement.
Okay.
Provide 20 milli equivalent of...
Provide what? 20 milli equivalents. Of what? Potassium ion. Okay.
And 3.34.
And what?
3.34.
3.34.
Milli equivalents of chloride ion.
Milli equivalent of what? Chloride ion.
Question is, how many grams of the powder will provide 6 milli equivalent of potassium?
How many grams will provide what?
Of the powder will provide 6 milli equivalent of the potassium.
This is also what? Proportion. It's simple. Once you know, okay. Let me get the marker. Continue.
And the next question is, how many milli equivalent of chloride ion
Uh-huh.
will be provided by this amount of power.
With what we got here? How many milliequivalent of what?
Of chloride ion
Uh-huh.
will be provided by this amount of power.
Good. By this amount. So we need to find it first before we can now look at the question again. Look up. The question said that the medicine is in sachet, right? Sachet is that is a supplement, right? That provide what is it called, potassium ion and the chloride ion. Now, but it's in powder form. It's in powder form, and 5 grams of it provide 20 milliequivalent of what? Potassium, and 3.34 milliequivalent of what? Chloride. Just 5 grams of it. We now ask how many grams will provide what? 6 milliequivalent of what? Potassium. So let's solve for what? Potassium. Now, if 5 grams provide 20 milliequivalent of what? Potassium. Let's set a proportion. Hello? Let's set a what? Proportion. Now, 5 gram provide what? 20 watts of what? Potassium. S gram, we don't know. We provide what? 6 milliequivalent of what? Potassium what? Ion. So let's find S. S is what? From this thing, S is what?
X is 20, sorry, X is 5 grams.
Times what?
Times 6 milliequivalent.
Good. Okay. Over what?
All over 20 milliequivalent.
Potassium, right? Okay. Okay, so we see that X is now what? 5 grams times what? 60 milliequivalent potassium ion over 20 milliequivalent of what? Potassium ion. You know how we arrive at this place. So let's the unit cancel first. This milliequivalent to do what? Cancel this milliequivalent. We are left with what? Gram. So 5 grams times 6 is what? 30 grams over what? 20. What's the answer? 1.5 grams. So if 5 grams of the salt will produce 20 milliequivalents, therefore 6 milliequivalent of potassium will be produced by what? 1.5 grams. Is it clear? Is it clear? Is it clear? Now, the second question says what? How many watts? Okay. Come here. You know this 5 grams is inside a sachet. It's a powder. It contains this and this. You know they are mixture.
This 5 grams is like a strength.
The weight of the entire everything the sachet is 5 grams. Now that 5 grams we deliver 20 milliequivalent of potassium ion and the 3.34 milliequivalent of chloride ion. You know it's a mixture. They cannot react. So you treat them independently. 5 grams. Here this one. The same 5 grams also do what? Here this one. The same way we treated codeine and the one tablet, codeine and hair. The same way now. Now, the second question says how many watts?
How many equivalent of chloride ion will be provided by this?
Good. Are you still confused? No. Ask me.
My problem was
Yeah.
this is This one is like in Kaketa particularly one sachet.
Okay.
Then this is another sachet.
Okay, now see what happened. See what happened. The question is how many gram? As in a 5 gram of this powder. This 5 gram will contain these two things. That means 5 gram will yield 20 milliequivalent of potassium ion. As like how many gram of this same powder can give us 6 milliequivalent of potassium?
Okay,
So which we got as what? 1.5 gram. Did they ask us again how many gram of what will be by this thing we got now?
Yes.
So for you to do that, that's when you start using this one.
Yeah.
The same 5 gram we produce this.
Then how many?
So 1.5 gram we produce how many chloride of chloride? Is it clear now? Is it clear now? Now, so at this point now, we solve for chloride, right? Right? Yes. If it's not clear, please let me know. You are cleared? Please. See how to solve question. If you practice it with the one you are given in the, like if you solve any, let me give you another secret on solving these things. Try to solve as much question you can on your own. Then, like these ones we did in this class, you try to change the figures by yourself and solve it by yourself and see how far you can go. Maybe from the one we did in class now, you can change figures on your own. Maybe where there is 2, you put 3. You see and see what you can get. Am I communicating? This will help you to really understand the topic very well. Okay? Now, look at this one now. We have gotten how many? 1.5 milligram can deliver 6 milliequivalent of what? Potassium ion. I just hear how many milliequivalent of chloride ion with this 1.5 gram of the entire powder deliver. You must go back to the question before you can solve this. From the question now, the same way 5 gram contains 20 milliequivalent. That's the same 5 gram. Also contains what? 5 gram also contains what? 3 point what? 4 milliequivalent of what? Chloride ion. So if 5 gram of the powder also contains 3.34 milliequivalent of what? Chloride ion. Now 1.5 gram of the powder. Sorry, thank you. Potassium what? It's okay, chloride, chloride ion. Then 1.5 what? Gram of what? No, this gram is the same powder we are talking about. Are you there? So this 1.5 gram of that same powder will now contain how many what? Good. Of what? We call it what? S. Is it clear now? This 1.5 is the same powder. Because 5 gram of the powder yielded 20 milliequivalents. 1.5 gram of the same powder yielded 6 milliequivalent of what? Potassium ion. Now, if the same 5 gram yields 3.34 milliequivalent of chloride, 1.5 gram of the powder will now yield how many what? Milliequivalent of what? Chloride. We call it what? X. So we make S the subject of the formula. S is now equal to what? 1.5 times what? 1.5 gram times what? 3.34 milliwatt equivalent of what? Chloride ion. All over what? 5 gram. Gram will do what? Cancel gram. We are left with what? Milli equivalent of chloride ion. So 1.5 times 3.34 divided by 5 is equal to what? Times 3.34 divided by 5 is what? 1. What? 022.
1.002.
Okay, so the answer is what? 1.0 watts milliwatts equivalent of what? Chloride ion. So 1.5 gram will give us what? 1.002 Milliequivalent of what? Cleared what? Ion. Is it clear? Is it clear? Good. This is also what? Proportion. Proportion is found in virtually 80% of the topics in PharmCalc employ what? Proportion. That's why I said that if you understand proportion, you can solve as many questions as possible. You know how I run my own. I put it back to you. You put down know exactly where you're having issues. Those topics you're having issues, the ones you know you are starting with, don't bother yourself on that one. The one you know you're having issues, call it. We will solve as many questions as possible in those topics. That's how this thing will run. Okay? Good. So are we done with proportion? So we enter under what? Measurement. Okay. Okay, we enter pharmaceutical measurement. Oh yeah.
You receive a doctor's order for 0.8 micromillimole.
Okay, call the question.
The question is, you receive a doctor's order for 0.88 microgram of the drug.
Doctor's order for what?
For 0.88 microgram.
0.88 microgram of what?
Microgram.
Okay, sorry, not milligram, microgram, sorry. Microgram. MC what? G. Okay.
The question is, what is the equivalent in milligram?
Okay, equivalent in what? Milligram. Forget all these long stories. All those things you are saying there is just long story. We just want you to do what? Convert 0.88 milligram microgram to what? Milligram. Simple. Forget those long stories. The question there is to convert what? Microgram to what? Milligram. So, and before you can solve this thing, you must know the relationship between microgram and what? Milligram. That's why we did metric system. We talk about the prefixes in metric system. Anytime you hear, listen carefully. Look at these two terms now. Micro. MC is what? Micro. This is what? Gram. This one is what? Milli. This is what? Gram. So the base unit here is what? Gram, right? This micro and milli are prefixes. Are what? Are what? Prefixes. And they have what? Values. The base unit here is what? Gram. When you add micro to gram, you have what? Microgram. When you add milli to what? This is gram, right? When you add milli to gram is what? If you add micro to gram, if you want what? Microgram. It's actually by letter is adding, but by value is multiplication. If you let me be using multiplication. If you multiply gram by milli, you form what? Milli what? Gram. So the base unit there is what? Gram. Now the value, these things are prefix. This is now what? Prefix is what? Base what? Units. Now the value of micro by name, micro is what? 3 raised to the power what? Minus what? 6. Why milli is what? 3 raised to the power what? Minus 3. You don't know? You don't know? It's minus. Plus kilo. 3 kilo. 3 raised to the power 3 is what? Kilo. Okay? Let's stop here. Let's focus on this plan for now. Now, this is 3. So, if 3 raised to the power minus 6 is micro, that means microgram is 3 raised to the power minus 6 times gram, which is what? 3 raised to the power 6 what? Gram. True or false? Why milligram is 3 raised to the power minus 3 what? Gram. So basically, 1 microgram is equal to what? 3 raised to the power minus 6 what? Gram. True or false? Why 1 milligram is equal to what? 3 3 raised to the power minus what? 3 gram. But we are told to convert from microgram to milligram. So we will find out how many. If you are moving this to gram now, we now do something like equate the two of them, equate their two what? Values. That means 0.88 watts microgram. If you use this now, if you move all of them to 1 gram, that means 0.88 microgram is now how many gram? If 1 microgram is 3 raised to the power minus 6 gram, 0.88 microgram is how many gram? See what you agree with me that 1 microgram is this, right? Now, if 1 microgram is equal to 3 raised to the power minus 6 what? Gram. Therefore, 0.88 watts microgram is now equal to how many gram? This times this, simple. Aria is 0.88 times what? 3 raised to the power minus 6 what? Gram. This forms a what? A microgram. True of us. Therefore, 0.88 microgram is what? 0.88 times 3 raised to the power minus 6 what? Gram. Are we together? Now, the same way, I'm doing a random teaching. After I will now solve the question, okay? The same way, if 1 milligram is equal to what? 3 raised to the power minus 3 gram. Okay, the question is in what? Okay, good. If 1 milligram is what? 3 raised to the power minus 3 what? Gram. Now, we try as much as possible to replace this gram here with milligram. With what? Milligram. If we can replace this gram here with milligram, we'll get the answer. Are you together? So how can we replace this milligram? Gram here with what? Milligram. Watch out. Let's you remember our standard form, law of indices. Let's split this 3 raised to the power minus 6. Remember that 3 raised to the power minus 6 is certain as saying 3 raised to the power minus what? Minus 3 times 3 raised to the power what? Minus what? Minus what? It's 3 now. Standard form. If we multiply this now, the power will add. You have minus 6. True of us. Now, if this is this now, that means this is certain as saying, are you aware that this is certain as saying 3 raised to the power minus 3 squared? Are you aware? That this is certain as saying 3 raised to the power what? Minus what? 3 what? Squared. I'm reminding you of your what? Standard form. Okay? Even though it's long, but I just want to remind you of your standard form. After I'll solve it in a short way. But I want to take you through all these things. So it remind you of this standard form. This is exponential what? Notation. That's what I'm trying to remind us here now. I don't want to just solve it boom like that. I want to give us opportunity to have a review of those topics that has anything to do with this thing, okay? You see that each of these topics are interrelated. None should be left what? Behind. I say you don't need it. You should be able to understand them before you can solve questions. Once you start having issues with one, it will start affecting the other what? Topics. That's how the course is what? Designed. Now let's go. Now, if this is this now, are you aware that this is the certain as saying, since you have agreed here now, are you aware that 0.88 microgram is the certain as saying 0.88 times 3 raised to the power what? Minus 3 times 3 raised to the power minus 3 what? Gram. Do you agree? Do you agree with me? I have splitted it now. Also, remember again that 1 milligram is what? 3 raised to the power what? minus 3 what gram. So wherever we see 3 square minus 3 gram, we can put 1 gram, 1 milligram there. Do you agree with me? Do you agree with me? So let's do it now. This is definitely saying 0.88 times 3 square minus 3 times what? 1 what? Do you agree? Do you agree? Do you agree with me? Huh?
Yes.
Good. Good. So
that is one. This is 1 microgram.
what? 1 milligram.
All of them are 1 microgram.
1 okay, yes. We are still working on this. No, they are what? 0.88 microgram. That's what we are converting now. So if that is the case, that do you agree with me that this is certain as saying 1 times this is the 1 milligram is times this is the same value. Are you agreeing with me that 0.88 microgram is certain as saying 0.88 times what? 3 square minus 3 what? Milligram. Do you agree with me? Do you agree with me?
Yes.
Do you agree with me?
Yes.
Look up. See where we started from. We said that the thing said we should convert it to what? Milligram, right? 0.88 microgram to what? Milligram. Simple. We move this to what? We move this to what? We find out the relationship between this and this. That 1 microgram is what? 3 square minus what? 6 gram. Then we now say, okay, let's if 1 microgram is 0.10 minus 6 gram. That means 0.88, we did it here, is equal to what? This times this, right? And we got this. But our mission, we are not converting it to gram. We want to convert it to what? Milligram. So now we now find the relationship between gram. We want this gram to disappear. We now find the relationship between gram and what? Milligram. That 1 milligram is what? 3 square minus 3 what? Gram. A bruiser to split here into 2, so we can get this, which we got here, right? We then replace this by with what? 1 milligram. And if you multiply it, you get this answer. Is it clear? Is it clear? Do we have any business with proportion here?
Yeah.
Is there any proportion here? So you cannot do without proportion. You can't do without what? Proportion. That is the root of the problem of many people that had issue with this course. And I said it from the beginning that you must, even if you don't have, you couldn't cover the whole topics, cover proportion. You may not get A, but at least there's no way you can fail the course. It's not possible. Because you know the question, if you see question, you know where to apply it. So this is once you're here now, this question, now for you to answer this question, you must understand the metric system. Remember where we are the value of micro and the value of what? Milli. You must understand that metric system. Another thing you must understand is what? Exponential notation. True or false? Then the last one is what? Proportion. You see how you apply 3 topics in answering single question. You see how the topics in Pharmaceutical are intermingled. If there's nothing like I don't want to do this one, you have to understand them. But the question some questions that you apply up to 4 topics to answer a simple question. Just simple question. Convert this to milligram. You apply your knowledge on 3 topics to solve it.
This 0.88, is it microgram or milligram?
Which one is that? Point, let me see. Good.
Is it microgram or milligram?
It has left microgram here. Okay. It moved from, watch, see what we did. We said 1 microgram. We are told to convert 0.88 microgram to what? Milligram. Now, you know that they don't have direct relationship. If I want to solve it, if I actually, let me sincere with you, if I want to solve it on my own, I won't go through the steps. See what I will do. Just see what I will do. From this point now, just watch out. If I'm solving this question on myself, like let's say I'm in exam hall, I'm going to this because I want to use the opportunity to teach you some things. See what I will do. Since the same microgram, since the same microgram is this, the same microgram is also what? Milligram is what? Now milligram is this. You split it here. If I split this thing now, I will remove milligram and put milligram. See how I will do it now. I don't need to write anything on my paper. See what I will do. Simple. Since 1 microgram is what? 3 raised to power minus 6 what? Gram. And 1 milligram is equal to what? 3 raised to power minus what? 3 what? Gram. I will split this into what? 3 raised to power minus 3 times 3 raised to power minus 3 what? Gram. Simple. Since 1 milligram is 3 raised to power minus 3 gram, I'll replace this with 1 with 1 what? Milligram. Which is certain as saying 3 raised to power minus 3 times what? 1 what? Milligram. True or false? Is it true? That means actually you can put it as this down as a conversion factor. That means actually 1 microgram is equal to what? 3 raised to power minus 3 what? Simple. So if 1 microgram is 3 raised to power minus 3 milligram, how many 0.88 microgram is now how many watts? Milligram. You can multiply. That means 0.88 microgram is what? 0.8 what? 8. We are ready for S now. 0.88 microgram. Remember, don't throw the unit away. Times what? 3 to the power minus 3 watts. Milligram. All over what? 1 microgram. Microgram will do what? Cancel microgram. We are left with what? 0.88 times what? 3 to the power minus 3 watts. Milligram. Isn't that the same answer?
Can we convert milligram to microgram?
Yes, you can. Perfectly.
With this question?
No, these questions. Unless if you get the answer, you can still move this back to what? Microgram if you want. But the question says you convert what? 0.8. The question says you convert from microgram to what? Milligram. That's what the question says.
But it's based on the question that you used to if you were driving this.
Yeah.
Based on the question.
Yes. But basically, on a general note, I don't care about these things on myself. Once I know the basic one, I can. On a general note, you may not see where they write that 1 microgram is 3 raised to the power minus 3 milligram. You see that they'll drive it here. The basic thing you see is that 1 microgram is 3 raised to the power minus 6 gram. 1 milligram is what? 3 raised to the power minus 3 gram. You see that will not say if 1 microgram is 3 raised to the power minus 6 gram and 1 milligram is 3 raised to the power minus 3 gram. Therefore, 1 milligram should be how many what? Milligram. You see that will do that one. And which I did and got this. Okay? That 1 microgram is what? 3 raised to the power minus 3 what? Milligram. Is it clear? So if you see this question exam, you can answer it perfectly. Right? So even if it is twisted, you can answer it. It's simple. The basic is to understand this. Why I went through all these things. I want to use the opportunity to teach some, not teach. We have taught this in class to do what? Remind us of these things. That's why I passed through. If I am done the writing exam, 5 seconds I have answered the question with this thing I did here. 5 seconds but if I had come here and started doing this, you may not understand it. That's why I took my time to do what? Break it down like this, okay? All right. This what?
10 minus 3. 10 minus 3 power 3.
0.00. It's not. It has a minus sign, so it should be 0.001. It should be 0.001. Okay. The same. Which topic is that? Okay, good. Wait, let me get the board. Okay, call it. Call it.
One teacup is equal to dash. Sorry. 1 teacup is equal to dash food ounce.
1 teacup is what to what?
Dash food ounce.
Uh-huh.
Is equal to dash meal.
Dash what?
Meal.
Okay. Is that all? Good. In our farm, in our this thing, what do we say about? Actually, when you say teacup, we actually mean cup. Okay, cup. Okay. So now, from what we did, we describe a cup as what male, as what number of male. Can you remember? Check your material again. Male is 1 tablespoon. 30 cup, no, it's not 30. 30 is food ounce. 30 is food ounce. Check your material. I want you to check it yourself. So what did you find out? Okay, let's not waste our time. Actually, you know, we have, I mentioned cup. Please, 1 teacup is not the same thing with every, you know, cup has different sizes, okay? But if we say teacup, we are what? Specific, okay? Now, 1 teacup, specifically, you know, if you say 1 cup is not, doesn't really make sense. So, 1 tea what? Cup is actually 120 ml. Okay? 1 teacup is what? 120 what? Ml. Are we together? So then 1 food ounce. 1 food ounce is what? 30 what? Ml. Even though an American system use 29 point something, but for practical purpose we use what? For practical purpose, you know, you cannot start measuring 29.25 or 29.775, yeah? So for practical purpose, we use what? 30 ml. So 1 food ounce is what? So use, anywhere you see food ounce in your exam, use 30 ml for me, okay? 1 food ounce is what? 30 what? Ml. So let's with these 2 things, you can answer this question. So if, let's start from here. Food ounce to ml is what? So we have what? 30 ml here, right? Now let's go back here. Well, look up. If 1 teacup is 120 ml, listen carefully. If 1 teacup is 120 ml, and 1 food ounce is 30 ml, so how many teacups will you what? 1 teacup is how many what? Food ounce. Listen carefully. I want you to answer this question now. If 1 teacup to ml is actually 120 ml, but 1 food ounce is 30 ml. So if 1 food ounce is 30 ml and 1 teacup is 120 ml, how many food ounce can we find in 1 cup? 4 food ounce. Is it clear? It's 4. Good. It's 4. Look up again. If 1 teacup is 120 ml and 1 food ounce is 30 ml, so how many food ounce can we find inside 1 teacup? How many? Okay, simple. How many 30 ml? How many 30 ml? Is 120 ml. 4. So that means since 30 ml is 1 food ounce, so we have 4 food ounce in what? 1 teacup. Is it clear? So here should be what? 4 what? Food ounce. So 1 teacup is 4 food ounce and 4 food ounce and sorry, what should we hear now? Is it 30 that should be here? No, what should we hear? I just use this to tell you that food ounce is 30 mil. So to answer this question, what should be here? What should be, how many, what value should be here?
That is 1 food ounce is, sorry, 30 mil is 1 food ounce. So
4 food ounce is how many now?
4 food ounce.
How many mil now?
4 food ounce should be.
Check well. You agree with me that 1 teacup is 4 food ounce, right? But 1 food ounce is 30 mil. So 4 food ounce is now how many mil? It's 120. 120 should be here, not that. Is it clear? Because 1 teacup is what? 1 what? 1 food ounce, right? 1 teacup is what? 1 food ounce. Then 4 food ounce is what? 120 what? Mil. Is it clear? Good. 1 what?
1 food ounce is equal to dash.
1 food ounce is equal to what?
Dash tablespoon.
Dash what?
Tablespoon.
Table what? Spoons. Okay. Yeah, that is TBS. Okay.
And dash, and sorry, 1 food ounce equals dash tablespoons.
Okay.
Dash mil.
Dash what?
Mil.
Mil. Is that all?
Yes.
This one is also simple. Now look at this. Look up. First of all, you should know the relationship between table. Before you answer this question, you should know the relationship between tablespoon and mil. Then know the relationship between food ounce and what? Mil. Before you can know what should be here and here. In rough, you should know the relationship. So there's 1 TBS, 1 tablespoon is equal to what? 15 what? Mil. We did this in your class, right? Good. 1 TBS is equal to what? 15 mil. And 1 food ounce is equal to what? 30 what? Mil. So answer this question. It's simple. You use the same method we use here. 1 tablespoon is 15 mil. Then 1 food ounce is 30 mil. So use the same method to solve this. You can get the answers that should be there. Two food ounce. 2 what?
2 food ounce.
Is it 2 food ounce or 2 tablespoons? It's 2 now. Here should be what? What should be here? Good. 30. So 30 should be what? Here. So actually 1 food ounce is 2 tablespoons. And 2 tablespoons is what? 30 mils. Is it clear? Good. 1 what? 1 quart is what? Dash what? Pint. Dash what? Mil. Now, for you to answer this question, you must know the relationship between pints and mil and quarts and pints. For you to do what? Answer this what? Question. So, from what we did in your class, how many pints are in 1 mil? Sorry, how many mil are in 1 pint? And how many mil are in 1 quart? So once you know the relationship between pints, if you know the relationship between pints and quart, it's simple. How many pints make 1 quart? It's simple now. Pints. It's two pints, it's not true. 2 pints make what? 1 quart. True of us? Good. So here should be what? 2. 2 pints make what? 1 quart. So 1 quart is what? 2 pints. But we know that how many pints make 1 mil? Sorry, how many mil make 1 pint? How many mils make 1 pint? Using the American system, that is 4 what? 473. 473. Now, 1 pint, 473 ml, right? Is what? 1 pint. So if 473 ml is 1 pint, how many ml should be here? By 2. Good. You get what? 8 what? Check well. Is it 8 or 9? Sorry, it seems I made a mistake. 473, 450. We have 453, so it should be 9 something, not 7.
I think 946.
Good, 946 ml. So 2 quarts, 1 quart is 2 pints. 2 pints is what? 946 what? Ml. 946 what? Ml. 40 what? 40 what? Fruit ounce is what? Dash what? Dash tablespoon. Then dash what? Milk. This one is also simple now. We have established something here before, right? What do we establish that 1/4, that 1 fruit ounce is how many tablespoons? 1 fruit ounce.
1 fruit ounce is 2 tablespoons.
1 fruit ounce? No.
Sorry. 15 tablespoons.
Okay, sorry. 1 fruit ounce is how many tablespoons? 2, right? Sorry, I'm sorry. It's what? 2 tablespoons, right? So if 1 fruit ounce is 2 tablespoons, 40 fruit ounce will be how many tablespoons? Good. Is it clear? Is it clear? 80 what? Tablespoon. How many milk can we find in 1 tablespoon? 15 ml. So if 1 tablespoon is 15 ml, 80 tablespoons is how many ml? That's 80 times 15, right? So what's the answer? 1,200, right? So here should be what? 1,000 what? 200. So 40 fruit ounce is what? 80 tablespoons, which is equal to what? 1,200 ml. Another one. Okay, call it. Come there. 'Attention what?
Attention prescription balance.
Uh-huh.
And the sensitivity requirements of 0.004.
It's arrows what? 0. What?
0.004.
4 what? Gram, okay?
Explain how you weigh 0.008 grams.
How you weigh what?
0.008 grams.
Uh-huh.
Of a substance with an error not greater than 5%.
Error what?
Not greater than
5 what? Call the question again. Attention.
Attention prescription balance
Uh-huh.
has a sensitivity requirement of 0.004 grams.
Okay.
The question is, explain how you weigh 0.008 grams of a substance with an error not greater than 5%.
All right. Remember what we said about this question. Before you can solve this question, this is aliquot, right? But in fact, we don't even know yet whether we can use aliquot. we need to do what? Find the least weighable what? Weight. I'm not complicating. What it means is this: we use sensitivity requirements and the error to find the least weighable weights. If we find the least weighable weight, we now know whether this weight here is above the least weighable weight. But if it's below the least weighable weight, you know, if it's below the least weighable weight, that means you cannot weigh it directly. We use what? Aliquot method of what? Measurement. Am I communicating? And I also remember the reason why we are checking these things. If the weight is above the least weighable weight, if the weight is below, if the weight you want to weigh, measure is below the least weighable weight, and you go ahead and use the balance to weigh it, do you know what will happen? The error you will get will be above what? 5%. And the permissible error in this weighing should be less than what? It should not be more than what? 5%. That's the meaning. Are we together? So now, let's look for, remember the formula we used to determine the least weighable weight. Remind us the formula. Least weighable weight is what? Is what?
Sensitivity requirement.
Over what? Error, right? Times what?
100%.
Are you sure? So if that, let's check whether it's true. That means it's the least weighable weight is what? 0. What? SR is what?
0.004
Over what?
5%.
Over what? 5%. Times what? 100 what? Percent. So this becomes what? This, we cancel this. 5% will divide 100%. We have what? 20. True or false? So 20 times 0.004 is what? 0. What? 0.0 what? 8 gram. Now this is the least weight you can weigh using this weight, using the weighing balance. But we are told to weigh what? 0.0. So that means what you want to weigh is 10 times less than the least weighable weight. True or false? 0.008 gram. 0.08. So we cannot.
This one is fine.
That means you cannot weigh it what? Directly. If you make mistake of weighing directly, what you get, we have an error more than what? 5%. So we use what? Aliquot method. Is it clear? I'm refreshing my memory now on this. Use what? The reason why you are using what? Aliquot method or indirect method. Okay? Now, you may see a question that may want to even test you whether you even know what you are doing. They may give you a weight, something that you do this calculation and get a weight that is above this weight, just to test you, know whether you actually know what you are doing. Then, if you want to expose yourself, after getting this thing now, this weight, maybe your least weight is 0.005 gram, for example. Now, sorry, maybe your least weight is 0.009 gram, for example. Now, maybe after this calculation, you are getting that your least weight is what? 0.009 gram, and you are told to weigh 0.008. Do you think you can use it to weigh 0.008 gram directly? Two of them, which one is 0.009 gram? This is the least weighable weight, and 0.008 gram. And this is the least weighable weight, and this is the weight we are asked to weigh. Okay, sorry, maybe you get 0.006 gram as least weighable weight, and you are told to weigh 0.008 gram.
This weight is higher than this one.
Which one is the least weighable weight? No, this is the weighable weight now. what you calculated. This is the weight you are told to weigh. Then after finding the least weighable weight, and you discover that the least weighable weight is what? Less than the weight you can weigh. So do you think you need adequate method? You don't get that's why a question can be twisted to test you whether you even know what you are doing. By giving you something like this, you find this weight. If you don't understand the topic, you get 0.06 gram. You go ahead and start it. Yeah. I will see and you start wasting your time on adequate method. And once you do it, what you see is bad. People don't even know when to use adequate method. So please, I'm trying to explain why we use what? Adequate what? Method. So if you are going to once you can calculate this and the least weighable weight is less than the what? Weight you are told to weigh. You don't need to do what? Stress yourself using what? Adequate method. Just simply say you don't need to use adequate method because the least weighable weight is less than the weight you want to weigh. This can be weighed what? Directly by just measuring it and put it. It's true of us. So I just struggle. Let me bring your attention to that. Now since we have gotten at since the least weighable weight is more than the what? Since the least weighable weight is more than the what? Given weight, we have to do what? We have to do what? Involve aliquots. Now let's remind ourselves of aliquot method. Now let's go to the what? Aliquot what? Method. Now let's go. Least weighable weight is what? 0.08 what gram. If we like, maybe to save material, we can start working with this. Remember, we look for a factor. Am I communicating? Now, that factor that's since this one is what 0.008. Now, what you now do is this. We need diluent, right? They didn't mention anything diluent, right? What did they mention? Okay, read the question again. Let's see. Tell me how you weigh what? Okay, call the whole question again.
Okay. A torsion prescription balance has a sensitivity requirement of 0.004 gram. The question is, explain how would you weigh 0.08 gram of a substance with an error not greater than 5%.
Okay.
Then they put weight, dilute weight, and
okay. So now, now what you now do is this. Remember, you cannot weigh this in directly like this because it cannot work. Now, but the least weighable weight is what? So what can you do to this? What do you think you can do to this to get a weight that should be up to this or more than this? What do you think you can do to this least weighable weight? Right? So if you multiply by 20, can it work? Can you get a weight that is equal to this or above this? Yes, it can work. In fact, 10 exactly will give you this. 20 will give you 0.16. Okay? 20 will give you 0.16 gram. But if you use 10 dot, it will give you what? 0.08 gram. Anyone you use is okay. Hello? Am I communicating? Now let's assume. Let's see what happens when we use 10. If we use 10 now, we have what? 0.08 gram. Okay? Now, what it means is this. You multiply this by this factor, because this factor will give you the least weighable weight, right? If you multiply this by 10, it will give you the what? The least weighable weight. Now, if you multiply this now, you get what? 0.08 gram. Now, remember what we are trying to achieve. We want to get a way that if you add both, if you weigh this thing now, if you add diluents from that mixture, you can take amount that will contain what? This. Remember that? Hope you remember. Now, if you at least with this now, you can actually weigh 0.8 gram. 0.08 gram now. Now, if you weigh 0.08 gram of the active of the drug itself, now, because you can now weigh it, if you weigh 0.8 gram, now what can you add? What can you add? What can you add to it to get, let's say, a weight maybe around 0.8 gram? That if you divide everything by 10, you still have what? 0.08 gram. Am I communicating? Let's see what I mean now. The target is this. The target of whatever you want to achieve here is that if you add diluent now, we have multiplied by 10 to get 0.08. Now, if you add a diluent, what diluent can you add to this now? That if you get, remember, you are no longer working. Here is, if this thing go down by 10, if this active ingredient go down by 10, you get this one. True or false? Now, but if this one is the diluent plus the what? Active ingredient, right? If you divide everything here by 10, this will go down by what? 0.08. This will go down by what? So if you actually weigh 0.08 gram of the entire mixture, it will contain this. So what amount of diluent can we add here to achieve this? Simply diluent. No, simply do this. This thing contains the diluent and the what? This 0.8 contains the diluent and the what? Drug. True or false? But this is the amount of diluent what? Alone. This is the what? The drug alone. Now, since you add diluent to this one to get 0.8, if you want to determine the amount you added, simply do 0.8 minus 0.008. What's the answer? Is it clear? What's the answer? 0. What? 0. What? 72 gram. Okay.
So this is the drug itself.
And diluent.
And diluent. And then this one is the
drug alone. Because you cannot weigh this. You multiply it by 10 to get the least weighable weight. You put it here. That's the drug itself.
Okay. Then this is the drug.
Yes.
Alone. This is the diluent.
And drug.
Which means that you added
diluent to drug.
To
get this.
Okay.
Is it clear now? So remember the factor we use to multiply now. Now having, what you do is just weigh 0.08 gram of the drug, add 0.72 gram of the what? Diluent, and get 0.8 gram of drug and what? Diluent. You can divide it with that factor again, the factor you used here.
Which means that 0. Constant.
Yeah, because diluent.
Is it constant?
Okay, because of this. See. Okay, let me start from the beginning.
My question is, where do you get this?
Good, I'm coming. Let me explain. This is aliquots. We want something that we get at the end. That if you take some quantity, weighable amount of this is drug and active agent. Active agent and the diluent. If you get, like now, let me start from the beginning. Let me clean up everything again. Where did the confusion starts?
I understand this 0.8 gram.
Here, right? Yes. Good. Is this the same thing with you? Now, if you understand this 0.08 gram now let's go. Whatever we are doing, the idea of whatever we are doing is that If we divide it by the factor we used, or any other factor, we still get you will still get 0.0 what? 8 gram. That means if you add diluent to this thing now, it will form diluent and active ingredient mixture. From that diluent and active ingredient mixture, you can weigh an amount that will contain 0.08 gram. Now, with this now, what amount do you think that if you put here at the end, if you weigh out some amount, it will still contain 0.08 gram? What amount can give you that you cannot, you can't add, you need to add something to it. It can be 0.008. It cannot be 0.8 again, because you must add what? Diluent. True of us. So it should be something bigger than this 0.8 by 10. Remember, by what? 10. That 10 you use here. So the best thing to do was still multiply this by 10. You get what? You get what? 0.8. What amount of diluent now are you supposed to use? Since this contains diluent and what? And drug. Simply multiply, subtract drug from where? Diluent. Is it clear now? And you get what? 0.72 gram. Is it clear? Now, with this now, what it means that if you weigh 0.08 gram of the drug, add 0.72 gram of the what? Diluent, and mix well, you get 0.08 gram of the what? Diluent and what? Now, how will you know what amount of this thing now? What amount of this mixture can we now get that will contain 0.008 gram? We divide this whole thing by the what? That 10, right? If you divide here by 10, is what? 0.08 gram, right? Even if you divide here, it becomes what? 0.72, right? Plus, if you divide here, it becomes what? Are we together? Is it clear? Sorry, 0.072, sorry. 0.072. Do you know what this means? You mean easy from this 0.8 gram of the drug diluent, merge well 0.08 gram of this mixture. 0.08 gram of this mixture will contain what? 0.08 gram of the drug and this thing. So to be able to weigh this thing now, to answer this question now, the question says dilute weigh 0.08 gram of what? Weigh what? Weigh 0.08 gram of what? Drug. Am I communicating? Dilute with what? Good. 0.72 gram of what? Diluent. To make what? 0.8 gram of what? Drop plus what? Diluent. Then do what? Weigh what? 0.08 gram of what? Drug and what? Diluent. Answer follow me. Is it clear now? Is it clear? No, that's why it's aliquot. That's why it's what? Aliquot. In case tomorrow you see yourself in one big company that there's a weight you need to weigh, you cannot do it with the ordinary balance they have. You use aliquot.
But how can you, find out the number that you're going to use? Like you found 10 here now.
Remember I said you can, the most important thing is that whatever you are multiplying must be above what? Must be equal to this or above it. That's the basic thing you should know. Remember I said you can use 15. You can use 20. A base is what? It should be less, it should be above, equal to this or above.
Can we multiply that maybe we get something like 0.8, not 0.8. Then can we solve it without can you solve it and still get answers? If we use what? 0.8. Here. 0.8 grams.
That means you are multiplying you are multiplying this by 100. How do you mean? How do you? No, if you are using 0.8 here, you are multiplying this by 100 fold. It's too much. You are wasting material.
Maybe
0.12 is what? 50. Fine. Because it's above this. You know, the more gap you. Okay, now let me tell you why I said that you are wasting ingredients. What out here? You get this big this direct you weigh here and get 0.8 gram. After you are going to take only 0.08. Others will be what? Waste. So if you go and get big factor, the more the factor, the more ingredients you are doing what? Waste. So try to be close to this. Either exactly this or a bit above it is okay. If you like, I can solve this one using 15 or 20. You see how I'll solve it. That's why I told you that no matter whatever you use, you must not use this one. What I need is, once you get the answer, it will come, because that's why I said that aliquot has no specific what answer. Depend on the one you use, depend on the factor you use here. But in practical sense, don't use large factor, because that thing you use is ingredient you're measuring. You waste them. You must take the same answer.
You cannot get the same answer.
If people are on the only time you can get the same answer unless you use the same factor. Are you there?
If there is a specific factor, any.
But I didn't give any factor. So you find any factor, but like you get the question. You score well, because so far you follow the principles. Factor is a problem issue. I will score it. If you got 100 for exam's sake, I will score it. But I will advise you in practical purpose, when you are doing it practically, don't use too much factor, because you waste those things. Let's assume that name whatever 500 grams. So you start taking only small amount. Others will be waste. Or yeah. Because what I'm measuring is what will give you this. True of us, in practical sense, but in exact theory list, I'll mark only your me. But I'm not practical exam. In the exam, skip the outer ego ingredients. Na lab. It's simple.
It's true.
Trust him. Okay. Okay. What's okay? I think we are, this is meant to be 2 to 4, right? Please try to be coming on time, okay? Huh? Okay, let's have one more. Then after. Call it.
Avoid errors greater than 5%.
To avoid what?
Errors greater than 5%.
Okay.
When using a balance sheet, sensitivity requirements of 6
6 what? To avoid error of what? Okay, just call the question. The whole question. Let me understand it.
Okay. To avoid errors of greater than 5%, when using a balance of sensitivity requirement of 6 milligrams.
Okay.
The pharmacy technician should not weigh an ingredient less than dash milligram. What is the milligram?
Good. I think with this, I like this question. This will explain what I told you about sensitivity requirement and this weight. So to avoid, we do calculation here now. To avoid, go back to the question again.
Avoid errors of greater than 5%.
So to avoid error of greater than 5%,
when using a balance with sensitivity requirement of 6 milligrams, the pharmacy technician should not weigh an ingredient less than that milligram.
Good. Now, that milligram has to get chopped with the least weighable weight. Simple. They gave you SR, gave you error. All that weight you are the pharmacy should not weigh below is the least weighable weight. So simple. Least weighable weight is equal to what? SR over what? Times what?
That's the acceptable error.
Yes. That's the acceptable error. Acceptable error is the error you should not go beyond, which is 5%. True or false? So that means LW is now equal to what? LW is now equal to what? 6 milligram over what? 5% times what? Which is what? This is 20. 120 what? Milligram. So the pharmacist should not weigh less than 120 milligram, so that he can not commit an error above what? 5%. So any weight he's going to weigh should be above 120 and above. And the more as the weight is going on, the error will be going down. Is it clear? So if we are to stop, please, I want us to be coming on time, okay? So that we can cover a lot. You know, I brought out 2 hours for this, 2 to 4 p.m. So that we can do one. Just as you go home now, those topics we solve questions on. Try to revise them again, solve more questions there. Then next week, let's solve more questions in other topics. Select questions from other topics. Let's look at them again. If you do it from now till end of September, at least there's no way you can't get into letter A in this course, even though it's basic. But at least you know that you're happy that you scored A, even though school will not give A, but you're happy that you do what? You made it. See, there's nothing like if you do something, you are fulfilled. I know this thing. You have the confidence that you know this thing. You don't know where you see yourself tomorrow. You know, I keep saying this, the world is global now. People do, I'm here controlling people outside the country with questions, solving questions. I have not even stepped out of I've not even entered plane for the first time in my life. But I'm here. I'm here doing something else just because of what by God's grace I was able to achieve by trying to study. At the same time, what internet can do. So that is what I'm making. Through my lectures I post online, people from different parts of the same questions. It's not because it's just that first of all you build yourself, you won't do that. So have the confidence to do whatever you want to do. So that's why I insist. If you pass through me, I don't believe in all this in your day. Try to learn that there's something you are missing that made it to this thing. And once you grab it, anyway, you see, you beat your chest. Yes, I did this thing myself. I know it. And you can answer it and be able to solve problems that may arise from it. Because you have a certificate. When you are done with here, you have a certificate can always only help you to secure a job. But when you are working that place now, other things that will now make you to progress is what do you know and what attitude do you have. 2 things. What do you know? Nobody will now say, okay, come and do this thing. I say, hey, don't leave him. I know he may not be able to do it. He may not do it well now, but he has distinction. It's nonsense. True of us. If you like, have upper credit, lower credit. What they want to know is, what are you doing there? What can they get from you? What can you apply there? Your ingenuity. So that's why I believe in knowing things, not just about passing the exam. Know that thing. It's very important. All right. Thank you very much. All right. Take care.